flooded. Yeah. So
Jesus.
just class of backups.
Dang. Okay, that's not good.
For Spanish.
No bueno. All right. That's all the Spanish I got. All right. So if we look at the document, and this will leave this up here for y'all, but you got to read it from your document. Who would like to read the we do problem for 15 points?
Me.
Go ahead, me.
An launch plane LP phonograph record rotates clockwise at 85.45 revolutions per minute. What is its angular velocity and radius per second?
Thank you, ma'am. So you got 15. Can you tell us what page can we find help on this at?
You can find help on page 270.
Thank you. Yeah. All right. So you need to crack open this book because there's some starter notes you need, and it comes straight from the book. The rest is going to come from the board. Usually in this class, the very first part is from the book. So I should expect you to type the whole thing, whatever it is, right? And then the rest, everything from the board.
Wait, so this is like the you reading from yesterday?
Yes, that's what I was trying to tell you. Yeah. It was a challenge yesterday. Now I'm about to explore it today. And then, of course, all the problems downstairs is either today's we do or yesterday's we do. You just change the numbers. I think you know how to do this, though, Mia. So you should be okay. All right, so 270 is where you got to go, like she mentioned. And what equation do we need? Not the same equation as yesterday, y'all. All right, this is where you got to use your Greek letters a lot. This is what you type. That's not a W. That's omega sub AV. Now, I'm pointing it out because I'm writing on the board, and y'all gonna give me the whole, what's that? What you mean? Go to 270. Try to type that box. That way you're not confused about what I'm writing, okay? Please type that box first. I'm going to teach about it for a second. All right, so Mia read the problem to us. So this is our we do. And this is, she mentioned, she noticed, this is you do number 3, actually, from yesterday. So I'll just switch the gears a little bit on you. And then there's some new problems that I can help you with. I think I gave you 2 new problems. I will try to do them over here if you need me to. I want to see if anybody can figure it out. You got to do some algebra for those.
Wait, for what?
So, let me see. So, just to give you a heads up, 1 and 2 is basically we do from yesterday. 3 is we do for today. 4 and 5, a little bit of algebra, but I'll show you how, okay? So let's start off with the equation we need for this segment. This is known as the average angular velocity, what we did with that up and down of force, right? Okay, so now we got that out the way. Let me get this a different one because it's not dark enough. This is omega, there we go. Omega, not W, use your subscript, AV, is equal to, right? And please write the sentence above the equation because it actually explains in words what it means. That's why I'm having you type the box. So that's delta. If you're confused about how to put this in your document, just act, don't suffer in silence. Theta is angle over delta T. We've seen this in, I want to say basic math where you have rise over run, delta Y over delta X. Sounds familiar? All right. So how do we do this? Well, anytime you want to insert delta, which means change in math and all of physics mostly, engineering, you type delta, that's a Greek letter. What about this thing that looks like a 0, but it's not a 0? Right? Please don't put zeros in. People have done it, and every time I saw it, it's -5. This is called theta. Put the right symbol in every time you use it. Theta, or the angle, is what it means, can be measured. Right? You also know this is an angle that you give you in degrees. In degrees, right? Or you could say radians. That's what the rads mean, or rad means. You have rad per second or radians per second. All right, I talked about delta, theta. Delta like this, they mean the same thing. It means change in, right? So final minus initial. You have omega sub AV though, that's in 2 flavors. Rads as in radians. You can put rad or rads. I put rads because it just makes sense to me. but most of the book will say rad, same thing. I've seen books that equip both. And the other way you can read it when you're doing degrees is revolutions per minute, or also known as RPMs. Like you see in your car, you hit the accelerator, and if you look very carefully as on the side, how many RPMs you're going. It's revolutions. How many times your tire turn per minute? Based on how much you push on the pedal. All right, so with all that written down, you don't type all this. You type what's in that box. All right? I wrote it there because I'm teaching about it, but I need you to type the box just the same, and then get the rest. This is page 270 at the very top. Okay, and maybe if we have time, I'll type a little bit with you, but 4 and 5, I got to try to do on the board because y'all probably don't know how to do that, right? That's a lot of algebra. All right, so where we find this at again? The box that takes care of this part of your notes, part 1 of your notes. There's double parts to it. Is found on page 270. The green box, everything. Please don't just type the equation. Type the sentence above it. How it's typed, it shows you what it means. Okay. Everything. All right, next part. As always, we got to talk about what's known in our problem, right? And what's unknown. And like if I'm quick enough, I'll clean this up. I'll do 4. I'll take this picture, put it in there, erase it, and do 5. I don't know if I have time to do it that fast, but just be patient with me. All right, so unknown. What did the problem give you, right? And what is the problem asking of you? To do this, we gotta look at the problem again and just pull out what we have. So this is a pretty quickly done problem. When you look at it, the name of the problem is actually at the bottom. It's done for you, the bottom of page 270. The name of the problem is called actually, what's the angular velocity? The other problem was done on the next page, and you see how long the CD problem was, if you need to go back and review. Okay? But you might have notes. So let's set it out. First things first, omega sub AV is equal to something, and they tell us that's 85.485 revolutions per minute, or also known as RPMs. Since it's going clockwise, we have to insert a negative symbol. That's why we did that experiment with the disc over there, right? So omega sub AV is equal to a negative 85.45, and we're gonna put rev per minute. I should have scooted the unknown over a little bit. I think I wanted to do that. Well, I think it's good enough. Just make sure you space it over some. All right, we need, the stars mean these are standard conversions. It's not multiplication. Just put a star. I think that's shift 6. No, shift 8 is the star. Or you can use your keyboard if you got it. All right, so put a star there. It means this is a little note. And you need you need some conversions that, if you don't know, you can pull from the book. Oh, I'm so impressed. Oh my goodness. Okay. Yes, Mia, you got it. Great job. She said 1 revolution. I don't know if y'all heard her. You can put 1 rev, because not everybody wants to write revolution all the way. Y'all be giving me a hard time, y'all pop up, man. Lord. 1 revolution is equivalent to, Mia said it, 2 pi rads, or radians, if you want to call it that, but just use rad, right? Because you'll see that a lot of calculus, a lot of trigonometry. So 2 times pi, right, times a radian, or you can put rad. That's one of our standard conversions. We need another one because, Mason, do you hear this? I told you this one. She already on it. Mia. Yes, Mia, you got 10 more points. She's literally telling me what to do. You got notes from yesterday or something, Mia? So 1 minute, you put MIN dot. You might not want to write minute everywhere, right? Is equivalent to, Mia said it's 60 seconds. We're gonna need that part because it's gonna help us convert down. All right, so what's unknown? Well, it's the same thing as omega sub AV, but it's in a different way of measuring it. So that'll be, technically, omega sub AV is equal to question mark rad per second, okay? If you write rads, it's okay, I understand. But technically the book wants you to put RAD/seconds, right, or sec. Now, I'm ready to begin converting, okay? So I'm gonna bring this down because this is I want to do a one-line conversion like I did. In fact, I'm just do it down here if that's okay, and just cross everything out and take a picture. Because I want to run into this box. All right, so what do? We state the case of what we're going to achieve. So we know this is part 3 of your notes. You say step 1. I'm going to solve for, yes, you gotta write that sentence. It tells the reader what you're thinking. Omega sub AV as rad per second. All right? It tells the reader, hey, I'm going to convert this from revolutions per minute to radians per second. Okay, so we got that done. Next, we rewrite it here and start our conversion process. So it's going to be a long conversion process. Give yourself some room. So we got omega sub AV is equal to, write it as a fraction so you can do your dimensional analysis for people that have you for physics. Parentheses, negative. I got 85. Don't forget to put your negative sign there. And I put rev up top. And that's per minute. That's what the per means. For every minute, that's how many times it's rotating, okay? Multiplied by, I gotta use one of my standard conversions that Mia had mentioned earlier. So I can use either one, just make sure you set it up so it cancels out correctly, okay? So I can use this one. Let's try the rev part and see if we can get out of rev and into radians. So if I say 1 rev, as in revolution, is equivalent to 2 times pi. This symbol, by the way, right here, y'all, is pi. Like on my arm, it's spelled P-I. It's a Greek letter too. Don't put P-I-E in there. You won't get what you need. All right? Times a rad. And I'm gonna slow down here for a second because I want to give away points to somebody, but you gotta tell me what you see. At this step, what cancels out? Got your hand up? Ridley? Yes? What cancels?
The one?
Nope.
Wait. I don't know. Wait.
You try it. What do you think cancels? Think about cross cancellation.
The radians in a minute?
No. You're right. So take 5. You try. Anybody else? Rev, not 1, just rev. See it? Rev divided by rev.
I cannot see that.
Yeah, this is why I'm doing this. It's called cross cancellation or dimensional analysis. Get a lot of it in physics though. Right. It's cool. So we cross them out. Mia, that was 10 for you. You still got your 5. You tried. I tried what we're trying. We're gonna keep going though, because our goal is not just to get rid of the revolutions. We got to get into seconds somehow. We got a conversion for that as well, right? So let's keep going. We're gonna use the next one Mia gave us, which is right here.
Wait, this problem is the same for the legal 3?
Okay, can I continue, Mia? Okay, she said, wait. All right, so what do? We set it up so we can get rid of our seconds, right? Or our minutes, I say. So I'm gonna say, hey, I know for a fact that 1 minute is equivalent to 60 seconds. That's SEC, I just abbreviated seconds. All right, here's another opportunity for 10 more points.
Minute.
Yes, ma'am, we saw it. Good job, 10. So we cancel it out. Now, all you do is you copy that whole thing and type hopefully a single line equation setup, and then you delete,
So it's negative 85.45 times.
Oh, you tell me what it's gonna be. Yeah, I think you're right, Mia. All right, let me bring it up. She's just spitting it out. So omega sub AV is now equal to what? She told us. The numerator she was saying is negative 85. Rev is gone times 2.
Times rad.
Yep, leave rad there. She's moving out. So 1 times 1 times 1, that's what's crossed out. So it's 60, she said, and seconds remain. Final step, calculate, but watch it, be careful. Remember, the engineering calculators, the new ones, you gotta check and see if you're in radians or degrees. That can hurt, right? Because there's different ways to measure it. For this one, I think you might have to put it in radians, but we're gonna see, because the number comes crazy, it's not right. So how do you check to see if it's in radians or degrees when you're using this? This is for the LAs as well, because you have students be like, I didn't get the same thing. Hit the house button on here. Go to My Documents, or I'm sorry, Settings, and then you see Document Settings. This one is in degrees, if you see that, right? So it might not give me the right answer. I'm gonna come down, I'm gonna change it to, because revolutions is for degrees,
So
whereas
if it's on radians, then what do you do?
if it's on radians, you leave it there, because if we have radians per second.
So after pi, you don't put anything?
No, you don't put that. That's just the designation. You put that in your document, but not in the calculator.
So you just divide it by 60 after pi?
Yeah.
Okay.
You got the pi button on here too, Mia. But just Mia, make sure yours is already in radians. I think you did that.
Yeah, like this? What?
No.
No, that's how you assemble. I already checked that it's
Oh,
in
okay.
radians. That's how you
Yes.
assemble.
Yeah, you could have used a fraction maker, but I think that works. Okay, so you had a question? Oh. So I'm gonna do like Mia did. I checked to see if I was in radians. That's important. Because if you see that you're calculating into radians, you gotta use radians. If you're using revolutions, you're using degrees.
It's 8.9.
I believe you, because that's what I was getting. Girl, let me check. You might be right. You quick, man. Whew. One of the veteran LAs is on her job already. All right, so I'm just explaining to y'all because I think she's right. You hit the fraction button. Mia did it the hard way, and that button's right by this little book. All right. Get comfortable with it because sometimes you type these fractions, you have a number at the bottom that pops out. So what do? I type what Mia did. I hope you get the little negative symbol here. Type 85.45, multiply by 2, multiply, they have a little pi button here. So use that. And then what else? I gotta come downstairs. Don't worry about putting the names and the dimensions in because you can write that in later. Just make sure it's in your document. Divided by 60, and Mia, what was that number you got?
8.9.
Positive or negative?
Negative.
Okay, and I'm gonna say it's 8.95 because we do 2 decimal places. So we're gonna take that 4 to a 5. So you got the 10 too, Mia, that's great. So Ms. Perez came up with the final answer, which was verified. If you get your symbol, it means it's going what? Clockwise. And we asking y'all that question on the quiz. What means negative, what means positive? You gotta tell me the difference between clockwise and counter. I think you got you said the right thing.
How do you do 4 and 5?
I'm going to try to do them as soon as I can write this box around this one. So let me hurry up because she wants that. And it's, ooh, I gotta be quick. Negative 8.95. And don't forget what is now measured in, right? Rad, as in radians per second. Okay? Box responses mean you are to try to highlight them in yellow, okay? Now I'm gonna hurry up and try to do the next problem that she asked about.
And the exponent number 3 is negative 12.
You might tell the LA team, because they're the one making demos.
Oh, yeah, making the deadline.
By the way, Mia, you got, yeah, you are. It's just all you gotta do 2 weeks. All right, I'm gonna do this one 4 and 5. Yeah, I told you she's done this before. Yeah, yes, Cortez.
What's that circle called?
Theta. Yeah, it's spelled like this right here. Yeah. All right, let me hurry to do this next one for y'all before we run out of time. And I promise if I can find time in 4th period, I'll type up how to do 5, right? But I'm gonna show you how to do 4. And the picture of how to do, I don't know if I can do 5 in the picture, but I'll try. Let me do this. Both these pictures will be in there though. Where is, So where are we at now? Let's take a look, right?
Is there a page for the equation for 4 and 5?
The same equation actually we're using is this. We're just doing algebra, Mia.
What do you mean? Like, what's the difference?
The way you do your algebra, what you solve for.
Is it that? Is that the difference?
Well, this is no algebra. We just plugged and played. Now we're gonna figure out, like, I think one of them is asking for that, another one is asking for this.
But it's the same equation.
It's just an algebra practice.
Well, you have to multiply?
We gonna see. How about we work it out, Mia? We gonna find out. All right, so let me hear her do this because it's kind of close to y'all lunch and GGI section. Time flies when you're having fun, right? All right, so number, let's start with number, so I think me and the team got y'all covered. Number 4, it's a CD. Did anybody want to read it for 10 real quick or no? Go ahead.
A CD rotates at 22.2 radians per second. What is its angular speed in revolutions per minute?
Awesome job. All right. So I didn't put a page number because I want you to think about it. So real quickly, this is asking the angular speed. So 4, y'all sure let me do it because the angular speed is this thing.
So that's
You said if you're known unknowns.
So that's what the unknown is.
Does that help or no? So can I do the hard way, which is 5?
What do you mean?
Uh-oh, so she still wants you to do it. All right, so let me try to squeeze this one in, but I think 5 has the super algebra because you got to figure out what this is by itself using your algebra, right? So I'm going to set this up and see if Mia can finish it off. 4, that was easy. Okay, let me show you. She said, what's easy? Students can stand when I say that. Use this equation again. Omega sub AV, right, is equal to delta theta over delta T. All right, that's the first part of your notes. Next, what's known and unknown? This makes things very clear. If you don't set it up, you'll be confused, right? So what is given to you in this problem?
So the unknown is revolutions per minute and the known is radians per second.
Right, but you're doing what? You gotta do a conversion. So the problem's the same as this, it's just they worded it differently.
Well, you gotta convert the radians.
Mm-hmm. So think about it. We had started with what here?
Revolutions, but that's what you need to find.
Yeah. But now they start you with what? It's going backwards, huh?
Now I started with radians.
Yeah, and you got to go back to revolutions per minute. So this is like the problem in reverse, Mia. So omega, let's write it again. Sub AV is equal to, and I'm gonna, like I said, if you can't figure it out, I'll try to type to it. I just want to squeeze in both of these. So, you know, it's still, is it rotating clockwise or counter? We're gonna ask that. It doesn't say, huh? So you saying clockwise? You gotta assume clockwise, it didn't say, right?
So it's a negative.
So, She's talking like a scientist. I want me to explain to Watson how she knew that. So she's right, it's a negative if we say just assume it to be clockwise. And clockwise is the normal rotation, that's why I said of a clock. So we saw, and the we do, was negative as well. Now if it says counterclockwise, it's not negative.
But so for the conversion, do you divide?
You do this, but you gotta change how you cancel. So let me finish. We got 22.2 radians per second. And be careful too, Mia, and others who are listening, you can't use radians for this calculation, can you? Can't use degrees, because we're going to revolutions. So be careful which way your calculator is set up. All right? Now, same things apply. These two, put them back, because you need those conversions. It's how you travel in between dimensions.
So what do you have to put it in degrees or radians?
Yeah, in degrees now, because you're going backwards. Like I said earlier, if you're using revolutions, it's degrees. If you're using radians, it's radians. So what are we working with here? Everything is still ticking. I thought I could shut up by now or something. We got also this here. And the goal is different now. And you simply got to find omega sub AV, but not in rads, but
In red,
per minute.
revolution.
Mm-hmm. That's
Per
why you.
minute?
That's what RPM means when you're driving, right? I don't know if you drive yet. Okay, so that's in that. Now, solving time. I'm gonna see if I can squeeze this in here. You do like this, but be careful where you put things to cancel out back to what you want. So, we take the case. Step one.
So we gotta use math and robotics.
Uh-huh.
See, we gotta use
The
math.
code name for robotics is called electrical engineering. Yeah. Please stop riding that little motorbike around, man. Somebody want to show off their little toy. All right, so what do we do? Omega sub AV is equal to a negative. Turn it into a fraction like you did last time. That's 22.2. Rad is up top. It's per second, right? Parentheses, keep it clean. Let me see if I can fit all this right here. It's kind of hard. So this is different now. We want to get rid of now what? Rads and get back into revolution. So we got to use one of our conversions. They stay the same. So how do we do that? Well, let's take a peek at how we put it in there. So if we look at this, rad is at the top. So I want rad at the bottom. I got to use 2 pi here.
So 2 times pi times rad, and then 1 rad on top.
Uh-huh. I told you you could do this. And then you got to tell me what crosses out. Somebody knows.
Well,
What cancels now?
the rad.
Yes. You thought you was asking me a question. She said, right. So we cancel. That's 10th morphobia. We got to do what now? Remember, we was in seconds. You got to go back into minutes because it's RPM minute. So I got to set it up correctly. I got a second down there. So I'm going to say, hey, 1 minute is equivalent to 60 seconds. Now, another opportunity somebody can figure it out. What cancels at this phase? Anybody know? Well, I'm gonna say for you because I gotta try to do 5 for y'all. You're gonna see. You think you know? Okay, come and take a look. You think you know? What cancels out right there? Yes, ma'am. Good job. Now, if you see what's left, we have what we wanted. We just got number crunch now. Rewrite it without the crossouts. So it's easy to figure out. Top the numerator is 22.2 times. Leave rev for n to set the speed. And that'll leave you in rev, when. And then this is gone. 1 times that stays. The minutes is remaining. Last part, calculate. Okay, I'm gonna leave this question mark and let you do that, but remember what its final dimension is. Okay. What is that? I'll let y'all do that part, okay? All right, y'all come over here because I gotta get y'all 5 over there. Trying to help y'all out. Why don't y'all circle this way? I don't be in y'all way. All right, so number 5, ceiling fan. I have one in my apartment. It rotates at a rate of 45. That little symbol up there is degree. I even wrote it in parentheses for you. And, it's kind of like when you look at the temperature. Degrees, 69, 45, there's degrees. You can't just say without that, right? So then it tells you it does this every 75 seconds. That sounds like a time. Seconds, huh? So let me think about it. I probably need to use either radians or degrees for this, right? And since the problem says degrees, I'm gonna say my calculator should be in degrees, right? Keep that in mind. So number 5, call this number 5. And I will take pictures of all these, so don't panic. We are getting that time where y'all gotta get lunch. This is where you do some heavy lifting, right? You gotta do some algebra. Okay? You're at a snacking, huh, son? Like, what is this wrapper on here? So, first part, you need this. So if you got it already, take it and recopy it for 5. Then you tell the reader, hey, what are my known unknowns? The question marks means you got to calculate it, y'all. So this is me forcing you to use that calculator to figure out the final answer. I'm already doing most of the work for you. Known. What do we know? Let's pick the problem apart as quickly as possible because you got 12 minutes, not 12 minutes, I got 7, maybe 6 minutes left. All right. It says 45. Yeah, I think it works that way. You're just not using the fraction maker, but it should work. This is delta theta, if you didn't know. That's the thing with the angle. Is equal to 45 degrees. That's how you write that. Delta T, I think your pi popped out, man. That's why I say use a fraction maker. See, that happens. Use a fraction maker and then it should keep everything at the bottom and everything at the top where it's supposed to be. Delta T, they gave you that. That's the seconds, right? And they said that was 0.75 seconds. What's unknown? Let's take a look. Well, the only thing in our equation we don't know, right, is what? The angular speed. So this is another easy one, huh? I thought I'd do some algebra. It gave you everything. So geez, let's take a look. We know that omega, so AV, is yet still the question at hand. Now what would it be measured in? Well, looking at the fact that it's degrees, it might be in RPMs. But they tell you to calculate it in radians per second at the end of the problem. Okay, so if the problem specific, use that. And if you see degree, don't get confused about it. So technically, we should still keep this calculator in terms of radians. Now, again, last part is just using what you got because you see the equation up there. So you say, see, you're going to say step one, there's only one step to this. It's just a workout of this equation over and over. Solve for just omega sub AV as they gave it to you. So we use that same equation again. Make sure you have all these steps. That's what we're going to final answer, y'all, all right?
We have 5 minutes, guys.
And I'm going to leave this for y'all to calculate because we're about to get out of here. I'll take a picture. Plug it in. Well, look at the problem. Is it clockwise or counterclockwise? It does not say. So we're going to assume it's going clockwise. So that's a negative. And, well, we can't say negative. We got to say delta. I'm doing it wrong. Delta this is this. So that's 45 degrees. And then that's divided by this. Remember the degree symbol, you just type DEG. You get that in your document, y'all. Calculate, I'm gonna let y'all do that. Just make sure your calculator is in radians because the problem said radians. Question mark, your answer should be in radians per second. Don't forget to keep your answer in.
You don't have to change your calculator?
Yeah, you do. If it's in degrees, change it to this.
Right.
Yeah.